everybody. We're going to talk about the unit circle today. So first we're going to talk about some angles and when they are in standard position. An angle is in standard position when the vertex is at the origin, so 0, 0, and one ray is on the positive x-axis. Okay, so if you look over here at our picture, we've got our vertex sitting on the origin, and one ray is on the positive x-axis. And if you look, that is labeled as the initial side. So your initial side is going to be the starting side. Which is always the positive x-axis if you are an angle in standard position. And then if you notice in our picture, there's another ray in our third quadrant here, and it's labeled as the terminal side. So the terminal side is the ending side. Oops, ending has a G. Okay, so you have where your angle starts and where your angle ends, initial and terminal. Also notice in this picture that there is a red arrow indicating which direction your angle is going. Okay, so that's going to be important to us here in our first example, because your angle can open up two different ways, clockwise and counterclockwise. So I'm gonna draw another little example here. Okay, and I'm gonna draw the exact same. We've got our initial side and our terminal side in the same place. However, I'm going to say that my angle is opening this direction. Okay, so for our original picture, this would be 0 degrees. And then, let me get a skinnier pen here. Up top would be 90 degrees, 180 degrees to the left, 270 degrees down at the bottom, and then all the way back around would have been 360 degrees. Okay, and that is going counterclockwise. Okay, when you are a counterclockwise angle, you are a positive angle. Okay, in our example that I drew, you're still going to start here at 0 degrees. Hold on, let me put that underneath it here. Okay, so 0 degrees. Then at the bottom is negative 90 degrees, so we're just going the opposite direction. To the left is negative 180 degrees, up top is negative 270 degrees, and then all the way around would be negative 360 degrees. So this is clockwise, and that is a negative angle measure. Okay, so now that we've kind of gone over that, it says find the measure of each angle in standard position. So if you look at part A, we are looking at this pink angle. And our pink angle starts here at 0 degrees, and it's going clockwise, which means we are going to have a negative angle measure. Okay, we've gone at least through negative 90 degrees. It keeps going through negative 180 degrees. It keeps going through negative 270 degrees. And then it goes this much more into our first quadrant here. Now that 45-degree angle is where the angle did not go, which is the remaining part of an entire circle. And we know that an entire way around is going to be 360. So if we do 360, take away that 45 degrees, you get 315. But since we know our angle was going in a clockwise direction, then that means that we have actually gone negative 315 degrees for our angle. You can also, this red arrow that I drew in the picture, if the blue angle is 45 degrees, my red arrow would also be 45 degrees because 45 and 45 make 90, and that's what the whole quadrant is. Okay, so you could have also done 90 plus 90 plus, well actually no, hold on, we went to 270 and then we went 45 more, so 270 plus 45 more still makes 315, you just have to know it's negative since we went clockwise. Okay, so here I'll just put two different ways to get it. Alright, for part B, we are going in a counterclockwise direction. And we start at 0, up here is 90, to the left, not negative, to the left is 180, and then down at the bottom here is 270, but we did not go all the way to 270. We went 60 degrees past 180, so if you do 180 plus 60 more degrees, you get 240. So since we're going counterclockwise, which we know is positive, our angle is a 240 degree angle. And part C. Okay, we are going in a clockwise direction, which is negative. We start at 0 degrees here, down at the bottom is negative 90, and off to the left is negative 180, and I'm going to stop there because our angle went only 20 degrees past the negative 90. So we've gone 90 degrees and 20 degrees more, so 90 plus 20, that's 110 degrees, but since this is a negative direction, we've gone negative 110 degrees. All right, now we have an angle measure and we are going to sketch that angle. Okay, so I will draw an X and Y axis here. We know the initial side of our angle is always going to be on the positive X axis. So you can go ahead and put that there. All right, so a 40 degree angle, this is positive, which means we need to go counterclockwise. Okay, here's 0 degrees, and up top is 90 degrees. Okay, we know we're going to be in quadrant 1 because it's 40 degrees, which is in between 0 and 90. It's less than halfway between 0 and 90, because halfway would be 45. Okay, so I'm going to sketch my angle a little bit less than halfway through the angle. Okay, I am going to indicate that we are opening up this direction, which is positive, counterclockwise, and I'm also going to say how far away from an axis we are. Okay, so this measurement is 50 degrees between our terminal side and our positive y-axis up there. Okay, so the red angle is our positive 40 degree angle, and you can say that the terminal side was in quadrant 1. All right, we're going to do the same thing. I'm going to draw positive, X and Y axis. Our angle is negative this time, which means we're going to go clockwise. So we have 0 degrees here. If I'm going clockwise, negative 90 is down here, negative 180, negative 270. Hey, look, that's kind of what we want. And then all the way around would be negative 360. Okay, so you can put your initial side where it always is, on the positive x-axis. And I know that my angle is going to be traveling around clockwise until it gets to negative 270, which is actually my positive y-axis here. Okay, so I'm going to indicate that my angle was going around this direction, and there is no need to say how far away from an axis it is because it actually landed on an axis. Okay, so I'm going to say terminal side on positive y-axis. And one more time. X and y-axis here. We've got 95 degrees, which is positive. So I'm going to be going counterclockwise. Got a 0. Up top is 90 degrees. 180 degrees, 270 degrees, and 360 degrees. Okay, so if we're going 95 degrees, my initial side, positive x-axis, like it always is, and I'm only going 5 degrees past my 90 degrees up top here. So I'm not going to go much past it, just a little bit. Okay, I'm going to indicate that my angle is opening up this direction. Now I could show the distance from that 90 degree y-axis until my terminal side, but that's a very, very small little area for me to draw between. So yeah, that's okay. I'm gonna do that anyways. Hold on, let me make this a little bit skinnier. That way maybe I can write something in between it. Okay. Alright, so I am going to indicate that this measurement right here is 5 degrees because it's 5 degrees past the 90 degree line. Okay, so I can say my terminal side, woo, my S got away from me there. Okay, terminal side in quadrant 2. And by the way, in case y'all forgot, this is how your quadrants work. Quadrant 1, 2, 3, and 4. All right, now, coterminal angles. Co means together, okay? And terminal is where our angles end. It's the ending side. So coterminal angles are angles with the same, can't spell today, with the same terminal side. Okay, so we've got a 575 degree angle. Okay, hopefully you know that since all the way around a circle is 360 degrees, that this is going more than once around our axes. Like we're starting at 0, going all the way through to 360, and then we keep going to 575. Okay, so we are told to find the measure of an angle between 0 and 360 that's coterminal with each given angle. If you're trying to get between 0 and 360, we're going to have to start subtracting from 575 until we get between 0 and 360. And what we are going to do is either add a full rotation of 360 degrees or subtract a full rotation of 360 degrees. So in our case, we're going to subtract a full rotation of 360 degrees, which gives us 215 degrees. Okay, so 215 degrees is coterminal with 575 degrees. I'm going to show you a picture of that really quick. Okay, so my 575 degree angle is more than one rotation around our axes. I can estimate fairly well where 215 degrees is though. If I put my initial side where it's supposed to be, on my positive x-axis here. If I go up here, that's 90. If I keep going, that's 180. Now 215 degrees is 35 degrees more than 180. So if I go a little bit more than a third of the way into this quadrant, that's approximately where 215 degrees would be. Okay, so 215 degrees is the red angle. Okay, now my 575 degree angle is going to start at the same place on the positive x-axis and end at the same place, terminal side, but this is how the green angle works. So you start out and you go one full rotation, okay, so 360 degrees all the way around, and then you go 215 more degrees, and it still ends on the same terminal side, and that's where 575 degrees would look like. It goes once all the way around, and then 215 more degrees to land on the same terminal side. All right, so now we have negative 356. So to get between 0 and 360, we're going to have to add. So we're going to add a full rotation of 360 degrees, and that comes out to 4 degrees. Okay, so 4 degrees is coterminal with a negative 356 degrees. So yet again, I'll show you the picture here. All right, so our 4 degree angle is going to be 4 degrees above 0, so not far at all. It has the initial side on the positive x-axis, and it goes up here, and it's 4 degrees. You know what, let me get a skinnier pen for that. Okay. Skinnier pen. All right, so starting here, 4 degrees, which is not much, okay, 4 degrees from the initial side to the terminal side. Okay, the 356, negative 356, is starting here, okay, it's going around this direction instead. Okay, so it's starting at the initial side and ending at the terminal side, just going the opposite direction. That's our negative 356 degrees. Okay, and negative 210, we have to add a full rotation to get between 0 and 360, so add 360, and that gives you 150 degrees. Okay, so a picture version. All right, so we've got negative 210. I'm actually going to graph that one first. Okay, so we've got our initial side here. Okay, if I go to our negative y-axis, that would be negative 90 degrees. If I go to the negative x-axis, that's negative 180 degrees. And negative 210 degrees is 20 more degrees, no, 30 more degrees than that negative 180. So I need to go 30 degrees, which is a third of the way into this quadrant. I think that's a little too high up. Hold on. There we go. Yeah, that's about a third, maybe. Let me try one more time. There we go. I like that one better. Okay, so this would be our negative 210 degrees. And our coterminal angle, that 150, is still starting on the initial side and just going around this direction 150 degrees. Now, you could have an angle measure that is so large that you have to either add 360 a couple times or subtract 360 a couple times. For instance, here I'll just throw another quick example at you. If we are finding a coterminal angle for 892 degrees, okay? So we would have to subtract 360, and let's see, 892 minus 360 gives us 532, but we're still not between 0 and 360. So I have to subtract 360 again, which would be 172 degrees. So you have three different coterminal angles here. 892 degrees, 532 degrees, and 172 degrees. These are all coterminal. All of them. But the only one that meets the condition of being between 0 and 360 would be this 172 degrees. So 892 degrees would go around twice and then go 172 degrees more. Okay, so if I was sketching a picture of that, 892 would start here, it would go around once, that's 360, go around twice, that's 720, and then it would go around 172 degrees more, which is only 8 degrees shy of being at this 180, okay? Something like that would be an 892 degree angle. And then our 172 degree angle would be the exact same thing, it just only goes from here to here. Hopefully that makes sense. Okay. So, now we're going to get into our unit circle, and we are going to talk about it more in our next day's notes. So right now I'm kind of just introducing it to you. If you plan on going to pre-cal, you will need to have this memorized, so that's why we're going to go over it again in our next set of notes as well. Okay, so first I want to review our special right triangles. I'm not going to use SOHCAHTOA. I'm going to use our special right triangles. Not even doing sine, cosine, and tangent. I don't think. Do I want to? Nah. Okay, so we've got a 30, 60, 90 triangle. I can draw another one that's technically still 30, 60, 90, just the 30 would be up top here. And then I can draw a triangle that has two equal angles. Well, that didn't go very well, hold on. No, I still can't draw a straight line, my goodness. There, sort of, okay, there we go. All right, 45 and can't. That's so terrible. Come on, Miss Underwood. That'll work. All right, 45, 45, 90. Okay. These two sides are equal on a 45, 45, 90. Okay, your special right triangles. Okay, this is your formula for a 30, 60, 90. On the side opposite the 30, you have a side length of 1. On the hypotenuse, it's double that, which is 2. And on our side opposite the 60 degrees, it's square root of 3. Okay, so I'll put the exact same thing on my second triangle here. So across from the 30 is a 1, on the hypotenuse is a 2, and across from the 60 is a square root of 3. Okay, on the 45, 45, 90, your legs that match are both 1s, and then your hypotenuse is the square root of 2. Okay, so these are your special right triangles from Math 2 that you should hopefully have learned about. Okay, so I'm going to scroll down here for a second. Okay, and this, I don't know why I'm missing a line here, is quadrant 1, and it's our unit circle is going to be all 4 quadrants, but this is currently showing quadrant 1 of our unit circle. Okay, so first, a unit circle means your radius is 1 because it's a unit, like 1 unit. Okay, so if our radius is 1, then that means each of these lines drawn in quadrant 1 has to equal 1. Okay, so I'm going to take this triangle. I'm going to see if my smartboard will let me do this. Okay. I'm going to be taking this triangle. Let me group these together. And I'm essentially going to be sitting it here. Now, I didn't draw it exactly. So, here. I am essentially taking that triangle and I am putting it right here. Okay, and this is my 30, 60, 90 triangle. Now, my radius is supposed to equal 1 because I said this is a unit circle with a radius of 1. And the issue is my triangle up here currently has a 2 on it. So what I have to do to fix that is divide it by 2, because then it will equal 1. Well, if I do that to one of these sides, I have to do it to both of the other sides as well. Divide by 2 and divide by 2. Okay, so on this red triangle I drew down here, my hypotenuse is 1, like I showed up here. The right side is now going to be a 1/2, and the bottom is going to be a square root of 3 over 2. Okay, so 1/2 square root of 3 over 2. Now I'm going to move, no, I'm not, okay. So, this ordered pair, if I'm trying to go to that ordered pair, if this is my origin, 0, 0, I will go to the right square root of 3 over 2, and then I will go up 1/2. Okay, so that's that ordered pair. Now, I'm going to go to my 45, 45, 90 triangle, and essentially I'm taking this triangle, which I'm going to group all together, and I'm putting it, oh goodness, Get it to drag. Come on. There we go. Putting it on our circle, but I didn't draw it to scale, so it doesn't exactly match up like I want it to. But this right here would be our 45, 45, 90 triangle with a radius still of 1. Okay, so on my triangle over here, you know what, I think I'm going to color code this. Let me change these to green. Okay, so it was 1, 1, and square root of 2. Okay, in order for me to make my radius, which is the hypotenuse of this triangle, be a 1, you divide by the square root of 2, because square root of 2 divided by square root of 2 equals 1. And so since I'm dividing by the square root of 2, I would divide these by the square root of 2. But if you remember from Math 2, you are not allowed to have a square root on the bottom. And so we have to rationalize our denominator. 1 over square root of 2, if I multiply by square root of 2 over square root of 2. Technically, I'm multiplying by a 1, but it's going to fix me having a square root on the bottom. So 1 times square root of 2 is square root of 2. Square root of 2 times square root of 2 is the square root of 4, which is just 2. So this equals square root of 2 over 2 if we rationalize it, and this equals square root of 2 over 2 if we rationalize it. Okay, so on my green triangle here, the right side is square root of 2 over 2, and the bottom is also square root of 2 over 2. So if I'm getting to this ordered pair, I go to the right, square root of 2 over 2, and up, square root of 2 over 2. Last but not least, I'm going to turn these guys blue. Draw a blue triangle on my picture. Okay, so I'm doing the same thing. I'm going to have a 30, 60, 90 triangle here in blue. Okay, there would be a 60-degree angle here, 30 would be up top here. So I still need my radius to be a 1, which means I need to go up here. It currently says 2, so if I divide by 2, that turns it into a 1. So I'm going to divide by 2 and divide by 2. Okay, so on the right, I have square root of 3 over 2. And on the bottom, I have 1/2. Okay, so to get to this ordered pair here, you go to the right 1/2 and up square root of 3 over 2. So 1/2 square root of 3 over 2. And I'm going to move my label for quadrant 1 here. There we go. Okay, so this is explaining where the ordered pairs come from. Whenever I go through the unit circle, I'm going to show you that there's a pattern to it, so you don't really have to remember how to get these ordered pairs using special right triangles. You just have to know the ordered pairs, and like I said, there's a pattern to it. All right, so I'm going to copy and paste this, I believe. Okay, so let me group it all together. And I am going to clone it. And let's move it to this page right here. Paste. Okay. So just as a little reference picture here, this is my first quadrant of the unit circle. Okay, so here I'm actually going to move it over where the first quadrant is located on our unit circle. Okay, so like I said, this is quadrant 1 for our unit circle because this is our origin, 0, 0. Okay, this would be quadrant 2. Down here is quadrant 3. That's not Roman numerals. Let me try that again. Quadrant 3. And then down here would be quadrant 4. Okay. So since we just talked about these ordered pairs, I'm gonna fill those in first. Okay, so I've got, let me get a skinnier pen here. Square root of 3 over 2, 1/2. Then I've got square root of 2. How did it go? Okay. Every time I change a color, apparently, I have to click on the skinny pen. Okay. This is not going to be fun. Square root of 2 over 2, square root of 2 over 2, and then skinny pen, 1/2 square root of 3 over 2. Okay. So that's those 3 ordered pairs. Now, I will work on filling in the rest of these ordered pairs. If I sit on my origin and I go to the right to this ordered pair, it would be at 1, 0, because remember our radius of this circle is 1. Radius equals 1. Okay, so if I'm sitting on my origin and I go across my radius to the right, I went to the right 1, so 1, 0. Okay, if I go straight up to where my 90 degrees would be, that's going to be at 0, 1, because I went left to right 0, but I went up 1. Okay, to the left, which I'm missing a parentheses here, whoops, that would be -1, 0, because I went to the left 1, and then up or down 0. And down here at the bottom would be 0, -1. Okay. Now I'm going to transfer the red, green, and blue ordered pairs to each of my other quadrants. Okay? Alright, so imagine folding this unit circle in half vertically. So along my 90-degree line down to the 270-degree line, folding on the y-axis. The red ordered pair, that's square root of 3 over 2, 1/2, is going to flip over and land square root of 3 over 2, 1/2 here. I forgot to get my skinny pen. Okay, square root of 3 over 2, 1/2. If I flipped over the x-axis, so I fold on the x-axis, I know that this red ordered pair in quadrant 1 would flip down into quadrant 4 and land right here, square root of 3 over 2, 1/2. I also know that if I took this red ordered pair that's in quadrant 2 and flipped over the x-axis, that it would land here in quadrant 3, square root of 3 over 2, 1/2. Now I just have to make adjustments for my signs. Okay, so if we're in quadrant 1, you go to the right and up, so they're both positive. If you're in quadrant 2, you go to the left and up, so negative, positive. In quadrant 3, you go to the left and down, so negative, negative. And for quadrant 4, you go to the right and down, so positive, negative. So all I have to do for these red ordered pairs that I have is make those sign adjustments. Quadrant 1, they're already both positive. Quadrant 2, I'm supposed to have a negative x value and then a positive y value. So I'm going to take a negative and stick it in front of my x value here. In quadrant 3, they're both supposed to be negative, so negative, negative. And in quadrant 4, my y value is supposed to be negative, so it's a -1/2. do the same thing for the green ordered pair. Let me get my skinny pen. Okay, square root of 2 over 2, square root of 2 over 2. If I folded my unit circle along the y-axis, the ordered pair in quadrant 1 is going to flip over and land in this ordered pair in quadrant 2. If I flip over the x-axis, they will land square root of 2 over 2 here, and square root of 2 over 2 here. Okay, so then I just have to make my sign adjustments since I'm already down here. These will both be negative. For the ordered pair in quadrant 4, the y value is negative. And for the green ordered pair in quadrant 2, the x value is negative. Okay, doing the same thing with the blue ordered pair. Okay, flipping over into quadrant 2, and then flipping down into, whoops, 1/2, quadrant 3 and 4. Get the skinny pen again. 1/2. Ooh, that's awful. Try that again. 1/2 square root of 3 over 2. And 1/2 square root of 3 over 2 in quadrant 4. Okay, let's make our sign adjustments. Both of these guys are negative. Y value here is negative. And x value here is negative in quadrant 2. Okay, so those are the ordered pairs. That was the toughest part. Okay? But it's really not all that tough because I mentioned there's a pattern, right? Okay, so if I start at an ordered pair where there's a 0, okay, so if I start right here at 0, that's a y value, so I'm going to focus on my y values and go through quadrant 1. I want you to notice it counts 0, 1 on the top, 2 on the top, 3 on the top. So 0, 1, 2, 3. Only the 2 and the 3 have the square roots because the square root of 1 is just 1. Okay? And the square root of 0 is 0. And the denominator, no matter what, in all of these fractions is a 2. Okay? So let me get rid of those stars. And I'm going to prove to you that it kind of works no matter where you start with a 0. Okay, so if I start here with a 0, it's in the x spot. So if I go and look at my x values in my ordered pairs, and it counts 1, 2, 3. It also counts through quadrant 2. 1, 2, 3. Yet again, square roots only on the 2 and 3 because the square root of 1 is 1 and the square root of 0 is 0. All of the denominators are 2's in these fractions. Okay. So I'm going to get rid of my little stars. Okay. I'll prove it to you. The bottom half works too. Here's 0, 1, 2, 3. 0 for the x value, 1, 2, 3. Still 0 for the x value, 1, 2, 3. 0 for the y value, 1, 2, 3. Okay, works, works, works. Lord, that's going to be a lot of undoing. All these little stars. Oh! Oh, geez. When I hit the arrow instead of the undo button. Gave me a heart attack. Okay. Now, back to these other blanks that are around our unit circle. Okay, so these are for our radian and degree measures. Okay, so these are going to be super easy because that's what we were talking about in our last set of notes, was changing between degrees and radians. Okay, so if I start here on my positive x-axis and I start at 0 degrees, okay, there is a little degree symbol there, I just kind of redrew it. Okay, straight up top is 90 degrees. There is a little degree symbol, I'm going to redraw it. Okay, to the left is 180 degrees. Down at the bottom is 270 degrees. And then all the way back around would be 360 degrees. Okay, if I'm sitting in quadrant 1, I know that that red ordered pair was from a 30, 60, 90 triangle. And I know that this little measurement right here in this corner by my origin was 30 degrees. Okay, so that means this is a 30-degree angle. I know that the green ordered pair came from a 45, 45, 90 triangle. So this angle right here was 45 degrees. Okay, so we've got 45 degrees. It's also halfway through the quadrant, so that makes sense. And then we've got our 60-degree angle here. So I want you to recognize that a big chunk like this is worth 30, and then a little chunk like this is worth 15 degrees, because 30 plus 15 makes 45, plus 15 makes 60, plus 30 makes 90. So if I'm going a big chunk, I need to add 30, so that's 120 degrees. Then I'm going through a little chunk, so I'm going to add 15, and that's 135 degrees. Then I'm going through another little chunk, so I'm going to add 15 more degrees, which is 150 degrees. And then I'm going through a big chunk, so I add 30, and that takes me to the 180. So I'm going to keep going. Big chunk, so add 30, which is 210 degrees. Little chunk, so add 15, which is 225. Little chunk, add 15, so that's 240 degrees. Big chunk, add 30, which takes us to the 270. Another big chunk, add 30, that's 300 degrees. Little chunk, 315. Little chunk, 330. And then big chunk, 360. Okie doke. So that was our degree measures all the way around. Now we're going to make our radian measures all the way around. So I'm going to point something out to you after I remind you that you can change all of these degrees to radians with our formula that we talked about in our 8.1 notes. Okay, remember that to go from degrees to radians, you multiply by pi over 180, and then you just reduce it. So for instance, 30 multiplied with pi over 180 would be 30 pi over 180. So you can change 30 degrees, and that reduces to 1/6. So it'd be pi over 6. Now, you don't technically have to do that for every single one of these, but you can. Okay, I know that halfway around my circle is 180 degrees, which we talked about the other day is the same thing as pi, right? Because I showed you that the radians, there was 3.14 going around the top half of my circle, and that's equivalent to pi. Okay, so if halfway around the circle is 1 pi, And then all the way around the circle, next to this 360, would be 2 pi. Oh, and by the way, 0 degrees is the same thing as 0 radians, because if you do 0 times pi over 180, it's still 0. Okay, so if I know halfway around is 1 pi, all the way around is 2 pi. So what if I'm up here at 90, that's a quarter of the way around, which is going to be half of a pi, because if 180 degrees is 1 pi, then half of that, 90 degrees, would be half of a pi. 45 degrees would be a quarter of a pi. And then 135 degrees would be 3/4 of a pi. Then technically you can, okay, so here, if I count around, if I go from 0 to pi over 4, that's 1/4. Then if I go up to pi over 2, that's technically 2/4. Then 3/4 at 135, and then 4/4, technically, because 4/4 is 1, at 180, and then it'd be 5/4, and then 6/4, but 6 over 4 reduces to 3 pi over 2, and then 7/4, and then 8/4, which 8 over 4 is 2 pi. Okay, so that was all of our quarters. Okay, now I labeled this 30 degrees with pi over 6. So that means every 30 degrees is a sixth of a pi, just like every 45 degrees was a quarter of a pi. So 30 degrees is 1 pi over 6. Then 60 degrees would be 2 pi over 6, but 2 over 6 reduces to pi over 3. 90 degrees would be 3 pi over 6, which reduces to 1/2. Then 120 degrees would be 4 pi over 6, but that reduces to 2 pi over 3. Then 30 degrees later, which would be at 150, okay, that would be 5 pi over 6, which doesn't reduce, so 5 pi over 6. Then at 180, that'd be 6 pi over 6, or 1 pi. Then 7 pi over 6. Then 8 pi over 6, but 8 over 6 reduces to 4 pi over 3. Then 9 pi over 6, but that reduces to the 3 over 2. Then 10 pi over 6, but that reduces to 5 pi over 3. And then 11 pi over 6. And then 12 pi over 6, which 12 over 6 reduces to 2, so 2 pi for all the way around. Hopefully that made sense. If not, you can always convert your degrees to radians using this formula I showed over here in blue. Okay, we'll go back over our unit circle again in our next set of notes. But for now, we're going to move on. Okay, this says find the exact values of cosine and sine for each angle. What you need to know is that cosine is your x value in the ordered pair, and sine is your y value in the ordered pair. Okay, so 315 degrees. I'm going to go back to my unit circle, find 315 degrees, which the ordered pair at 315 is this one, square root of 2 over 2, negative square root of 2 over 2. So I'm going to write that down. We've got square root of 2 over 2, negative square root of 2 over 2. Okay, this is your x value, this is your y value. So cosine of 315 degrees. Remember I said cosine is the x value. So we equal the square root of 2 over 2. Sine of 315 degrees is the y value, so that's negative square root of 2 over 2. Okay, next we've got 3 pi over 4. So I'm going to go back to my unit circle, find 3 pi over 4, and that's this ordered pair, negative square root of 2 over 2, positive square root of 2 over 2. So I'll write that down, negative square root of 2 over 2, positive square root of 2 over 2. Okay, so the cosine of 3 pi over 4, remember cosine is the x value, so that's negative square root of 2 over 2. Sine of 3 pi over 4 is the y value, so square root of 2 over 2. Okay, negative 30 degrees. You kind of have two options here. You can get a coterminal angle for 30 degrees, or you can just go around the unit circle in the opposite direction 30 degrees. Okay, so if I find a coterminal angle, I would add 360 to negative 30, which would be 330 degrees. Okay, so a negative 30 degree angle is the same as a 330 degree angle. Okay, so for negative 30 degrees, remember that would be starting here and then going down negative 30 degrees, which if you look is the same as a 330 degree angle. Okay, so we're using this ordered pair, square root of 3 over 2, negative 1/2. Let me get rid of my drawings here. Okay, so square root of 3 over 2, negative 1/2. Square root of 3 over 2, negative 1/2. All right, so cosine of negative 30 is the x value, so square root of 3 over 2, and sine of negative 30 is the y value, negative 1/2. Okie dokie. Now, you've got negative 2 pi over 3. So you can do one of two things. You can add a full rotation to get a coterminal angle. And a full rotation for this is going to be 2 pi because 360 degrees and 2 pi are equivalent. So if I find a coterminal angle, I'm going to do negative 2 pi over 3 plus 2 pi. But I have to find a common denominator. Okay, to get 2 pi to be over 3, I would have to change it so that it has a denominator of 3. Well, what number divided by 3 gives me 2? 6 does. So 6 pi over 3 is the same thing as 2 pi, which means these two added together give me 4 pi over 3. So negative 2 pi over 3 is coterminal with 4 pi over 3. Okay? You can also just go around the circle in the opposite direction. Okay, so here, let me go back. This was negative 2 pi over 3. Okay, if I find regular 2 pi over 3. Okay, here's regular 2 pi over 3. If I start at my initial side, I have to go through one quadrant and then 30 more degrees to get to 2 pi over 3, correct? Well, since I'm going in the negative direction for negative 2 pi over 3, I would go down through one quadrant and then 30 more degrees, which would land me on 4 pi over 3, which I said was coterminal with it anyways. So this is the ordered pair we're using. -1/2, negative square root of 3 over 2. Let me get rid of my drawings here. Okay. One more. There we go. All right. So at 4 pi over 3, our ordered pair was -1/2, negative square root of 3 over 2. So cosine of -2 pi over 3 is the x value, so that's -1/2, and sine of -2 pi over 3 is the y value, which is negative square root of 3 over 2. Okay, so using your unit circle is when it says exact. Okay, that means use the unit circle. Now, if it says approximate or round, something like that, then you can use your calculator. Okay, you just have to make sure that if you're doing like sine and cosine of 315 degrees, that you're in degree mode. And if you're doing sine and cosine of 3 pi over 4, you need to be in radian mode. Okay, so if I do, let's do sine and cosine, I'll keep it in the same order. Cosine of something that's not on my unit circle, so we'll say 310. And sine of 310. And then I'll pick a radian amount that's not on my unit circle. I'll do cosine of, let's see, 4 pi over 3, and sine of 4 pi over 3. Okay, so here you have to be in degree mode, and here you would need to be in radian mode. Okay, so let me pull up my calculator really quick, and I'll just show you guys this. Okay, so if I hit the mode button, I then have to be in the correct mode, which is down here on the 4th line. Notice it says radian or degree. Currently, degree for me is selected. You just hit enter on degree. It turns it black, and then you can hit clear. So if I do cosine of 310 degrees, we get about 0.64. Okay, so I'm going to say 0.64. If I do sine of 310 degrees, we get approximately negative 0.77. Okay, now if I switch my mode to radian, and then hit clear, I can do cosine of 4 pi divided by 3, which would be negative 0.5. Wait. Did I mean to write 4 pi over 3? No, I think I said 4 pi over 5 earlier. Yeah, let's pick something that's not on my unit circle. Because that's on the unit circle. 5. There we go. Okay. Make an adjustment. Because I believe I said 4 pi over 5. I just didn't write it. Okay, so let me get my same entry here, just change that to a 5. And we've got negative 0.81. And then if I do sine of 4 pi over 5, I get 0.59-ish. Okay, so exact value means use your unit circle. If they tell you to find a decimal or approximate value, you use your calculator. Okay, your homework is on Delta Math. So 8.2 Delta Math.